Hello everyone, let's solve today's daily problem. I won't be doing a separate explanation part today because I'm a little tired, but let's go. Okay, so this will be a live solution. Now I know that this problem, I think it's right. Dijkstra's, my friend told me, but let's see. Okay, you're given an n-to-n integer matrix. Grid represents the elevation. Okay, you're given a grid and then that represents the elevation. It starts raining and water gradually rises over time. At time t, the water level t. Okay, at time t, water level is T, meaning any cell with elevation less than or equal to T submerged. You can swim from square to another care. Mm-hmm. Okay, so return the minimum time, reach the bottom right square. Um, you can swim a square if adjacent square if and only if the elevation of both the squares individually are at most T. I mean, this seems pretty simple, right? You find a path to the bottom right such that, okay, so here you find a path to the bottom right such that the least, like the height of the greatest cell should be minimized. So here that would be what, 15. Okay, so it'd be like that. So that would be 16, I guess. Yeah, that would be 16. So the answer for this is 16. Okay. Now, how do we do that? Okay, so what can we do? Uh, Let me pull up my drawing board. Okay, right. Okay, so we start from the origin, right? Now, hmm, okay, let's have a distance n is equal to length of the grid. Okay, and now distance is equal to, initially let it be infinity. So infinity, right? And now we need a visited, I guess. So we need a visited set, and we also need a heap. Do we need a heap or a queue? Um, no, there's not distance. Let's say like highest or like best or something like that. Okay. Okay, so now in the heap, okay. So initially heap push, um, and then we need the origins height. So that would be grid of 0, 0, and then 0, 0. So let's just see if everything's working. Print heat and then print best versus good. Okay, so 0, 0, 0, and then best is supposed to be. It's, yeah, that was a small mistake. Now I should have 4 infinities. Yeah, perfect. So yeah, that's fine. And yeah, 0, 0, 0. Okay. So while he um you can move, swim in any of the 4 directions. So directions is equal to, and what are the 4 directions? 0, comma 1, and then comma minus 1, 1, 0, and then minus 1, 0. So these are the 4 directions. So while heap, let's say the current and I and j is equal to heap bar, right? And then so what we need is, okay, so hmm, so the best of I and j is equal to maximum of current, or okay, it cannot be that, right? So it has to be minimum, okay, minimum of best of that, or maximum of. So let us, okay, initially what we can do is we can just set it to grid of I, comma j itself. Okay, so best is equal to grid dot copy, right? Second. Let's say we're at 23. So when we heap push, okay, it's 24, right? It's best of I and j, and then current. And is it the minimum of that or the maximum of that? It's the max of that. Whatever the max of that is, right? That's not right. Okay, so it has to be current itself. This is initially infinity itself. Infinity. And then it's best of or seems fine. So if we so if 0 less than n lesser n if it's not there, then it's heap push heap and then best of I and j. Seems fine. Return best of Oh, wow, first try. Damn, that was impressive. What is this network error? The internet's pretty slow today. What's wrong? Okay, time limit exceeded. Okay. Hmm. No, I didn't look at the constraints, but let's check it out first. So n is 50. Now, why am I exceeding time limit? So NING not unvisited. Okay. Okay, I think it should be here, right? So if I okay, did I even add it to visited? Okay, I did. JN visited. Uh, cutting. Right. I did the same mistake in another problem box. It should be fine now. Yeah, what happens here is that we, yeah, even after adding it to the queue, if some other cell, so let's say we add this to the queue, but it's still not visited though, right? Uh, we need a condition here because, yeah, we're adding it multiple times here. Uh, for example, there might be a cell such that it hasn't been visited yet, but you can add it multiple times to the queue. So this can be multiple times in the queue. Is that, wait, am I tripping? Well, let me think about it for a second. Why do we need one here? Okay, we might not have visited it yet. Right. Now that makes sense. So, let's say from this, we add 13 and 22 into the queue. Now, both of these are next to 14. So, both of these are going to add 14 to the queue. So, 14 is there multiple times in the queue. So, to prevent that, after we visit 14, we don't have to visit it again. And that's why we have another visited check there. And that's how it works. So, yeah, hopefully you guys understood this. Essentially, what we're doing is using the Dijkstra's algorithm. We're having we have this matrix called best. So now this best for any cell, it gives you the least height uh, that you need to travel through, which you have to reach the cell. So, and now we need the answer for the last cell. So we're returning that. So that was the solution. Thank you for watching.